Maybe I'm going to write the problem. Here's the problem. Art. And it's the total mass of say 1,100 kilograms. Then we're going to calculate the acceleration of the sun. And say normal velocity.
Sir, good morning po.
Morning.
Sir, hindi gaanong maririnig yung boses mo, sir.
Ganon. Hello, naririnig niyo na ako?
Sir, hindi po gaano, sir.
Ayan, naririnig niyo na ako?
Yes, sir.
Yes, okay. At tinanggal ko yung phone ko. Baka yun nga ang diferensya niya.
Humina po ulit, sir.
Humina ulit?
Yes, sir. Hindi gaanong audible.
Humina ulit yung boses ko?
Opo.
Pero naririnig nyo pero mahina.
Yes, sir. Mahina po.
Siguro it has something to do with mulan kasi. No? And kung mulan, medyo humihina talaga ang signal dito. No? Okay. So lalaksan ko na lang yung boses ko. Yes? Naka full volume naman na ako. Teka, i-check ko yung full volume. Yan. Okay na? Okay na, mahina pa.
Yeah, okay na, sir.
Okay. So let's continue with this problem. Reactions. Okay. On the pair of frictionless wheel okay at A and B. Okay. Then we're going to neglect the mass of the wheel. Yeah. Any problem. So take note, class, that we are applying now an equation of motion in this case, class. That is applicable for translation only, no? So, drawing natin yung cart na yan. Parang ganito yan. May handle yung cart para yung ginagamit nyo sa kung bibili kayo ng mga So, grocery store, di ba may cart na ganyan? Okay. Ganyan yung cart niya. Okay. And then, may gulong dito, ganyan. May gulong din dito. Okay. And these are pairs of wheels. And, nandito yung floor. Okay. Now, may center of gravity yan, G. Okay. And then, okay, ito yung A natin, B natin, saka ito yung A. Okay, syempre kung magtutulak ka, nandito yung force. Parang ganun yung force. Ano? Oh, yes, ayan. Say, ang force na ito is 100 Newton. Okay. And say, merong itong slope na 3, 4. Applied at this point in here. Okay. Say, this is point C. And then, lagyan natin din ng mga dimension, ano? Okay. Say, usually ang taas nito is, ano ba kataas yung cart? So, this is 1.2 meter. Ayan. Ganyan. Okay. And, say, ang distance naman nito, okay, sabihin natin ang mga distance yan. Okay. Say this is say this is 0.4 meter. Tapos, say this is 0.3 meter. And 0.3 meter din ito. Tapos, yung location ng kanyang center of gravity, okay, has a height of, say, 0.5 meter with respect to the floor. Ayan. Now, in this problem, it is stated that the wheels are said to be frictionless. So we do not we disregard friction forces. And we also neglect, we're not going to neglect the mass of the wheels. Okay. Mass of the wheels. Now, this cart is carrying a load of, it is a mass of 100 kilograms. So yung mass niya is 100 kilograms. And if we're going to draw the free body diagram, okay, of the cart, one force would be acting on on the center of gravity. So I will use uh, red color. And this is actually resultant rate. This is m times g. And then this 100 kilonewton force, ito na yung force na nagtutulak ng cart. Ay, meron siyang component along Y. Okay. So this would be 100 Newton times, if this is a 345 triangle, then this Y component force would be 100 times 3 all over 5. Okay. At yung X component naman niya would be 100 times 4 all over 5. Okay, ratio and proportion yan, ano? And then may reaction din dito. Okay, say this is normal reaction at B, and this is normal reaction at A. Now, wala tayong friction force because it is idealized that as if these wheels, pairs of wheels, are frictionless. Yan yung wheel ng car natin. Okay. So, we assume that we have 4 wheels. Dalawa sa B, saka dalawa sa A. And we're going to determine the reactions on this pair of wheels. Okay. So, ito na yung free body diagram of the card. Okay. This is now the FBD of the card. And it is moving in the X direction. Yan ang kanyang motion. So it is translation. This translation along x-axis. Okay. So nakuha nyo yung problem, class. Now, using the kinetics equation, our equation for motion would be that would be we're going to sum forces along X. Tanggapin ko muna ito. This would be the mass of the card times yung acceleration niya along X. Okay. Acceleration niya along X. And this acceleration, okay, is acting on the centroid of the card. Okay. So this is the acceleration, okay, applied at the centroid of the card. Okay. So yung unbalanced force natin dyan ay dapat ganyan ang kanyang direksyon para yung acceleration niya naman ay ganyan ang kanyang direksyon. Okay. So, pwedeng burihin ko na ito, no? Para pinakita ko lang na dapat consistent ang ating direction. So, we can say, class, that the only force that's acting along x-axis is the component of the applied force along x. And that would be 100 times quantity 4 all over 5. Okay. Okay. And this will be equal to the mass, okay, total mass of the cart, okay, siguro including yung mga kinarga natin, times the acceleration along x. Okay, now please remember, class, that this formula is extracted from the second law of motion. Extracted from the second law of motion. And so we can now solve for AX, okay, which is equal now to, magka-cancel itong 100, okay, so this would be equal now to, simplified as 4 all over 5. 4 all over 5 is, okay, complete nyo nga, 40 divided by 4 divided by 5. Is it 0.8 meters per second? Okay. Now, for the second part of our solution, okay, we are going also to some forces acting along y, and that would be mass acceleration along y. Yung acceleration along y is a component acceleration also applied at the center of gravity. Okay, but since there is no motion along y, okay, the sum of forces along y is simply equal to 0. And taking that class, that is yung ay natin ito is 0, because there is no translation or motion along y. Okay. And this second law, no, was reverted into a first law, which is yung equilibrium of forces along y. Okay. And so, viewing our free body diagram again, we can see that there are several forces that are acting along y. Okay, and we have the normal reaction at B plus the normal reaction at A. Then that would be minus mg, yung resultant weight ng cart. Okay, and then minus yung component ng applied force natin, which is 100 times the quantity 3 all over 5, and their sum is 0. Their sum is 0. or this is your n sub b plus n sub a minus 100 times 9.81 and minus 100 times 3 all over 5 is equal to 0. Now, if we can let this be equation 1, and saan natin kukunin yung isa pang equation niya. Another equations of motion would be the sum of the moment of the forces at G, okay, would be equal to I alpha. Okay. But notice class that there is no rotation that is happening here. Hindi nagro-rotate yung ating part. Otherwise, kung magro-rotate yan, hindi na yan cart. No? Hindi na yan natin magagamit yan. So, there's no rotation. Okay. And we can say, class, that since there is no rotation, okay, this is equal to the sum of the moment at the centroid is equal to 0. Okay. And all we have to do now, class, is to apply this becomes an equilibrium equation in a sense that summation of moment about G is simply equal to 0. Now, let us have a sign convention here na yung counterclockwise moment would be positive. Okay. Tandaan nyo yan, class, no rotation yan because we are just dealing with translation, no rotation. Okay. And so looking again at our free body diagram, G would be our moment center. And we can see, class, that there are several forces that will have moment about G. Okay. Unahin muna natin yung mga may positive moment. No? So, ang naka-positive no moment dyan is NA. Okay. So, NA will impart a positive moment and it has a perpendicular distance with respect to G of 0.3 meter. And then another positive moment about G is yung vertical component force at C, which is 100 all over 3 all over 5. Okay. And it has a distance of 0.7. 0.7. That would be 0.4 plus 0.3. Is 0.7. Okay. And then normal reaction NB would have a negative moment. So that would be negative NB. And ang moment arm niya with respect to J is 0.3 meters. And then, of course, we have also 100 times 4 all over 5. Yung horizontal component force will also impart a negative moment. So we have the expression 100 times 4 all over 5. And its distance with respect to G would be, yung distance niya would be what? 1.2 minus 0.5, no? One point two minus 0.5. And yung mg natin, of course, will have no moment about G because doon tayo nag-moment sa G. Okay. And of course, everything is equal to 0. Okay. So we can let this be equation 2. Okay. So paano na natin isosolve yung dalawang unknowns? Okay. Paano? So notice, class, that from equation 1, this equation 1 natin. Okay. You can also have this as NB. Okay. Would be equal to 100 times 9.81 plus 100 times 3 all over 5 minus NA. Okay. So maybe we're going to have this as equation 1 prime. Okay. Equation 1 prime. And if we're going to substitute now, we're going to substitute, okay, equation 1 prime in equation 2. Okay. Hence we have now NA times 0.3 plus 100 times 3 all over 5 times 0.7 minus NB, which is equal to, okay, 100 times 9.81 plus 100 plus 100 times 3 all over 5 minus n sub a, and everything is multiplied by 0.3. And ay, ba? Okay, tama. And their sum is 0. So we can now solve for n sub a. Yung reaction sa A in Newton. And using now from equation 1 prime, we can now solve also for n sub b in Newton. Okay. No? So, bahala na kayo mag-solve dyan. So, we can see, class, na yung step natin, madali lang, 1, 2, 3 lang yan. 3 steps lang yan. Okay. So, ganyan po yung yung acceleration natin is 0.8. Okay. And then, yung NA natin, okay, at saka yung NB natin, both in newtons. Okay. Okay. So, bahala na kayo mag-solve dyan. Ha? Bahala na kayo mag-solve. So, this is translation. This is translation. Okay, next problem. Hmm. This is a classical example also of a rolling motion. Okay. So, parang ganito, no? We're dealing with, again, we're going to have an inclined plane like this. And then, say, this time it's a cabinet. Okay. Cabinet na ganyan. Tinatamad na akong magsulat ng problem, no? Siguro intindihin nyo na lang yung draw. So, cabinet na ganyan. Yung cabinet natin. And then may gulong. Okay. May gulong ang cabinet natin. So, lagyan natin ng gulong. Okay. Meron siyang wheel. Meron siyang wheel. And, okay. And, nandito yung center of gravity niya. Okay. Ito yung kanyang G. Lalagyan din natin ng mga dimension. Say this would be, distance ito would be, say, 1.5 meter. And then, ang distance ito, say this would be 0.5 meter. And say ang mass nitong cabinet na ito is palagay natin na this is a mass of 100 kilograms. 100 kilograms. And it is moving in this manner. Yan ang kanyang motion. It is a rolling motion. Remember, walang laktulak sa kanya no? Pababa siya sa inclined plane. So say ang inclined plane na ito ay meron itong angle na say 20 degrees. Yung theta natin is say 20 degrees. Ito yung inclined plane natin. So this is a cabinet. Ganyan. Okay. Now of course we also assume this time that the wheels are frictionless and it is a rolling motion, frictionless wheel. Yung assumption natin. Yan. And what we're going to solve here is we're going to solve the reaction of the wheel at B and at A, and also the acceleration of the cart. Also the acceleration of the cart. Okay. Now we're going to draw first the free body diagram. So ito yung this represents now the resultant weight of the cart. Ganyan. Okay. Directed along the vertical. So ito yung kanyang weight. Okay. Yung weight of the car is of course equal to M times G. Okay. Yan ang weight ng car. And then this can be broken down into its two components. Say ito ang x-axis natin. Gawin natin na ang x-axis natin is okay, pababa yung positive. And then y natin is ganyan. Gawin natin ganyan yung positive axis natin. And so if we're going to resolve this W into its two components, one would be directed along x-axis. Now notice, class, that this angle in here between the normal and the line of action of W, ang angle dyan is also angle theta. It's also equal to 20 degrees. Okay. So, ang component natin along x would be written as this should be mg times sine of theta. So this would be mg times sine of theta. At yung component niya along y naman, which is visualized as downward, this would be mg cosine of theta. And then meron din tayong normal reaction at B and also at A. Ganyan. Okay. So we're going to find the acceleration of this. Ano yung acceleration niya? Of course, pababa yan in the direction of X. And ano yung acceleration niya? Okay. Along Y. Of course, obviously, it is 0. Okay. So, what we're going to find in here is ano yung AX niya. Now, take note that yung AY is 0 because there is no motion along Y. Okay. No motion along Y. And we're going also to solve for the normal reaction. NBY. Ayan. So, plus, this is still translation, but we are dealing with rolling motion. And then friction force are also 0. Friction forces are 0. So this is not the complete free body diagram of the card. Okay. Showing now the components of the weight, mg sine theta and mg cosine theta, and that the reactions at A and B. This time we're dealing with an inclined surface. The cart is moving down the inclined plane. Okay. So the first solution would be what would be the sum of forces acting along Y. That would be equal to M times acceleration along Y. And you know, class, that this is 0. So from second law, naging first law siya, di ba? Okay, kasi hindi applicable yung second law. So, na-revert yung equation natin to first law, which is, we consider this to be equilibrium. Okay. This is an equilibrium equation. So, nag-equal to 0 yan, equilibrium. Okay, sana maintindihan nyo yung pinagsasabi ko rito, no? And so, looking on the free body diagram, all forces acting along Y, we have NB, and we have NA. And that would be minus mg sine of theta is equal to 0. Okay, so we can see that NB plus NA would be now equal to 100 kilogram times 9.81 times sine of 20 degrees. Okay, or NB plus NA would be, okay, complete nga ito, 100 times 9.81 times sine of 20 degrees. Could you?
Sir, 335.52.
3,
35.52.
335.52.
0.52, sir. 52.
Newton. Makikita natin, class, na dalawa pang unknown dyan. Okay, we need another equation. Meanwhile, let this be equation 1. Parang ganun lang ang pattern, ano? Dali-dali lang pala ito. No? Okay. And for the second equations of motion, obviously we have now summation of forces acting along x would be equal to mass times acceleration along x. Now take note, thus yung mga acceleration na ito is always acting at the center of gravity of the cabinet. And what is that unbalanced force along x? So that would be, we have mg, okay, cosine of, oh, I'm sorry class, this should be along y natin, this should be cosine. Okay, correct na ito. Cosine dapat ito. Cosine. Pag i-compute nyo nga ali, cosine 20 degrees. Nakita na.
921.84, sir.
Ah,
921.84 po.
0.84 Newton. Okay. Because dito, summation of forces acting along y natin would be mg along y natin sine of theta. Is equal to, nag-iisang force lang naman yan, ano? That would be 100 kilogram times a sub x. Okay. And your a sub x will be equal to okay, m times g pa ito. Okay. M din ito. So, ikakansya na natin yung m, no? Dahil we're referring to the same mass. So that your a sub x would be simply equal to 9.81 times sine of 20 degrees. And we have an acceleration of
3.36 po.
3,
3.36.
okay, 3.36 meters per second. And it is directed down the incline. So, ginawa nating positive kasi ito yung positive x natin. Positive x ito, positive y. Yeah, 3.36 meters per second. Ngayon, paano ba? The third equation of motion natin is we take moment at the center of gravity, which is equal to 0. Kaya nang ginawa natin dun sa O. Okay. Remember class that ang talagang equation na ito is we have this as again this as I alpha, diba? Okay. But since we have no alpha, ang alpha natin ay 0, hindi naman siya nagro-rotate along G, walang rotation yan. So this is therefore equal to 0. Again, class, I'd like to note here that there is no rotation. Okay. About G. And so our equation is reverted again into an equilibrium equation. We simply have the equation summation of mole of G is equal to 0. It is reverted into an equilibrium equation. And let us assign again our sign convention. Pakikot natin ang plastic. So our moment center is G. And what are the forces that will have moment above G? That would be NB, NB at saka NA lang, no? So that would be NA, okay, times a moment arm of 0.5 minus NB times a moment arm of 0.5 also. And the sum of the moment at G must be equal to 0. Therefore, we have the expression NA is equal now to NB. Magkakansel dito. And so we let this be equation 2. Now take note that mayroon na tayong answer sa kanya acceleration. Okay. And further take note plus that yung AY natin dito is 0. Okay. So if we're going now to substitute equation 2 in equation 1. And we have now the expression 2NA is now equal to 9.21.84. 9.21.84. And so our NA would be equal now to 921.84 divided by 2 lang Newton. And therefore, your NB is also equal to the same din ang kanya. Okay? So, pag-compute. Ano yung NA at NB natin?
Sir, dyan po sa NA is
460.92 po.
90.
400?
460.92.
400?
60, sir. 0.92.
460.92 po. 460.92.
Pares sila, di ba? Yes?
Yeah. Yes, sir.
So kung yung NA natin ay 460.92 sa dalawang gulong 'yon, di ba? Kasi we assume na 4 ang gulong niyan, di ba? Dalawa sa NA, dalawa sa NB. So bawat gulong will have a reaction of what? Okay. For each wheel, that would be 460.92 divided by 2. Yun yung ano. Remember class, ito ang reaction sa per K. Paris yan ha, yes? Kuha nyo class?
Yung 460.92 divided by, ano yung divide, sir? Yung 4 na gulong?
O, 4 na gulong yan, di ba?
Okay.
So kay drawing natin yung ano niya, yung parang 3D niya, ganyan yan eh. Diba? Nandito yung isang gulong, yung dalawang gulong, nandito din yung dalawang gulong, no? Yes? Yes? Kuha nyo? O, may reaction dyan. Okay. May reaction din dyan. So, ito yung NB divided by 2. And then, third term yung NB divided by 2. Then, dito naman, yung reaction dito is dalawa rin, di ba? Yan, yan. Ito yung NA divided by 2. Ito yung NA divided by 2. Siyempre, apat ang gulong yung cabinet, di ba? Yes? Paano, class? Paano? O, ito yung cabinet natin,
Yes,
di
sir.
ba? Yan. Cabinet natin. Okay. Yan. Yung figure kasi natin is seen as a two-dimensional figure, di ba? Okay. Alam ka naman, tig-isang gulong lang yan, di ba? O hindi na, hindi na siya stable, di ba? Bangke-bangke. Okay, would you like to have a screenshot of this? Okay, so next meeting class, we're going to discuss more. We're going to discuss centroidal rotation. Okay. With translation. Okay. We're going to discuss also non-centroidal rotation plus translation. Siguro magbusa muna tayo sa pure na centroidal rotation, and then i-upgrade natin ng plus translation, and then pure non-centroidal rotation, and then isang problem sa plus translation. Okay.
Sir, screenshot din po, sir.
Screenshot nila. Medyo mahaba yung lecture natin.
First part.
Medyo sinipag lang ako ngayon. Kasi malapit ng sahuran. Okay. Ayan. Screenshot mo.
Wait lang.
So, puro translation problem muna tayo. Ngayon, sa ngayon. Okay na?
Next na, sir.
Taas ko na?
Okay.
Buuin nyo.
Next na, sir.
Yung free body diagram.
Next na po.
Okay na?
Yes, sir. Sa baba.
Okay na?
Wait lang sa may gulong. Gulong po.
Okay na, sir.
Sir, wait lang sa may gulong.
Sa may? Ito, balikan natin.
Okay na, sir. Okay na, sir. Doon na po sa solving na part.
Ito, okay na yan?
Next na, sir, sa 3.
Next na, sir.
Oh.
Next na, sir.
Okay na?
Yes po.
Okay na, sir.
Rolling motion.
Bahala kayo sumagot yan, ha? Okay, ito, rolling motion.
Next na po, sir.
Okay na, sir.
Ayan.
Next na po, sir.
Okay na?
Okay na, sir.
Next na, sir.
Okay na?
Next na po, sir.
Okay na?
Yes, sir.
Tapos na, sir.
Okay. Now, wag muna kayong bibitaw dahil meron akong pre-discussion dun sa centroidal motion.
Okay na, sir.
Yun na.
Okay na, sir. Okay na, sir.
Now, I'd like to clarify, class, that yung equation natin na moment about G is equal to I alpha. Okay. Yung I natin dyan is called this is uh, mass moment of inertia. Of inertia. At usually ang unit niyan, class, is ano ba yung unit ng mass moment of inertia? Kilogram meter square yata yan. No? Mass moment of inertia. And yung alpha natin is the angular acceleration. Okay. Which is unit of radian per second square. So that yung moment natin would have a unit in Newton meter. And what's this? Kung katitingnan natin yung unit class, ano, I times alpha, we have kilogram meter square times radian per second square. And this will have a resulting unit of kilogram meter square per second square. Okay. However, if you're going to factor out kilogram meter per second square, magpa-factor out yung ating meter. But this expression class, itong expression na ito, is also equal to Newton. Remember, class, that 1 Newton is equal to 1 kilogram meter per second square by definition. And so, yung resulting unit natin will be Newton meter. Yan ang unit sa atin. But what is this moment? What's this I in here? What is this I? Ano bang physical meaning na? What is the meaning of this I? What is the meaning of this? No? Now, moment of inertia, or we also call this, sometimes it's called angular mass. Or sometimes it's also called as rotational inertia. This is actually class A. This is actually class A. What do you call this? A parameter. Okay. That determines the torque. okay, uh, needed for a desired uh, angular acceleration, referring to your alpha, about a rotational axis. Okay. So when the mass is allowed to rotate at g, g is the rotational axis or rotational point. Okay, rotational point. And yung sinasabi natin na torque dito, class, is yung mismo ito. So we also call this torque. This expression is also called torque. Okay. Instead of saying moment of forces, we also call this torque. Okay, torque. Siguro dahil sa mahirap panggitin ng moment of forces, simply say that this is torque. Okay, or summation of torque, no? Okay. In some cases, ang symbol niyan is T instead of M, no? Now, paano ba kasi ito? Ano bang itutulong ng mass moment of inertia na ito, or itong tinatawag nating angular mass? This is analogous to summation of forces is equal to mass times acceleration. No? Kung titignan natin yung dalawang equation na yan, summation of moment, okay, is equal to I alpha. Okay. So dito uh, ito kasi, class, is yung first equation natin is dealing with rectilinear or translational rectilinear motion. Okay, rectilinear motion ito, while this one is rotational motion. Okay, kung titingnan natin yung mass natin dito, this is called mass. Okay, at ito yung kanyang rectilinear acceleration. Okay, at ito yung unbalanced force or accelerating force. And we have an analogy here. This is analogous to this. Ito yung kaniyang analogy na kung saan doon sa umiikot din na bagay, kaya siya nakakaroon ng rotational motion. Meron siyang angular acceleration din. Okay? Dahil merong unbalanced torque. Ito yung kanyang unbalanced torque. At ito naman, yun yung tinatawag natin na rotational mass or simply mass moment of inertia. So the word inertia, class, pag sinabi nating inertia, okay, this is a property of a mass that it is a measure. This is a measure of a body's resistance to its change in motion. Okay. Nag-change lang ang motion ng body kapag body's axis. Okay. Okay, so merong magre-resist sa pag-change na acceleration ng body, and that is inertia. In the case of a rectilinear motion, mass is the measure of the resistance of the body to changes in the velocity or changes in the motion. Ganon din. Sa umiikot na bagay class, meron din magre-resist dyan. Ang tawag natin dyan ay rotational mass. Okay. Now, applied to machinery, meron tayong tinatawag na flywheel. No? Okay. Ano ba itong flywheel na ito? No? Okay. I'd like to discuss this explicitly because kailangan nyo ito kasi abe ang course nyo. No? And ang tinutukoy ko na dito is some implications on the design of machineries. So, for example, ano itong flywheel? For example, meron kang shaft na ganyan, and then merong motor na ganyan, motor. This is the motor. And then, nandito yung support bearing support ng motor. Yan yung bearing support niya. Okay. And then usually, class, this system is being provided with a flywheel. May flywheel dito. Na mas malaki yung mass niya doon sa motor. Okay, so ito na yung flywheel. Yan. Okay. Now, the flywheel is supposed to be a this is meron siyang heavier angular mass or heavier I. No? Ito naman ay lighter angular mass. Ano bang purpose kung bakit nilalagyan natin ng flywheel? No? Alam natin kasi iikot ito, no? Iikot ng ganyan yan, iikot din yan, no? Okay. Why? Okay. So ito very
Generate electricity po.
somebody's now have a ano. So hindi i-set aside muna natin kung ano yung magagawa ng motor, pero ang gusto kong ipaliwanag dito is ano ba yung magagawa ng flywheel na yan sa pag-ikot ng shaft dito sa motor. Okay. Now, naglalagay tayo ng flywheel dyan. The reason why flywheel is being installed dun sa mga bagay na motor na umiikot, may umiikot dyan, shaft. Ito yung shaft ng motor natin. Siliklas na inatas natin sa shaft ng motor yung flywheel na yan. Okay. Okay, so maybe merong isang shaft pa rito para pandarin nyo yung isang machinery.
Sir Buen?
Yes?
Sir, excuse me po, pero may next class po kami, sir.
Okay, sige.
Sir?
Sandali lang, can you spare me mga 30 seconds lang?
Yes, sir. Sige po.
Okay. Now, nag-install tayo for the reason, ano ba yung function ng flywheel is to, because it has a larger moment of inertia, okay, it can, ang purpose ito, yung heavier moment of inertia of the flywheel, okay, is Uh, ang purpose nito is to smooth, to have a smooth, uh, to smooth out rotational motion. Okay. No? And also to conserve rotational kinetic energy. Kung saan kung and then yung fluctuation of power, no, is being minimized. Fluctuation of power is minimized so that the motor will rotate. Okay. The motor is will rotate more stable. Right? Kung tatanggalin na yan class na yung flywheel, hindi na smooth yung pag rotate ng ating shaft ng motor. Okay. At hindi na siya makaka-conserve ng kinetic energy. So, yan lang ang practical application ng moment of inertia. Okay, class? And thank you again for for joining. And then let me have the attendance. Okay, see you next meeting. Hopefully. Thank you, Ken. Thank you again, class. And ano na tayo? Mag sign sign off na ako.
Thank you, sir.
Bye, sir. Thank you po.
Thank you, sir.